Can you all hear me back there? Well, I'm done? Okay, good. So I'm John Huth. I'm a physics professor. My main research gig, if you like, is experimental particle physics. So I collide protons together at very high energies at this facility outside of Geneva, Switzerland. And through kind of an accident, yes, literally through an accident, I started getting interested in navigation writ broadly, and then one thing sort of cascaded into another, and so now I have kind of a large range of interests, which includes meteorology and weather predictions and sort of the history of how that evolved. So the movie that you're about to see is inspired by true life events, but takes a few liberties with them, as often happens, to make it more dramatic. I'm not going to be a complete spoiler, but I am going to be a stickler for one point. So the protagonist at one point is trying to finance a balloon ascent, which was an attempt to make a world record, highest balloon ascent, but also do measurements of weather, like the temperature, barometric pressure profile at different altitudes. And his interest, he professes that he wants to learn how to predict the weather. And in presenting this to the Royal Society, he gets laughed out of there. Like the other scientists think it's absolutely ludicrous that anybody could imagine possibly predicting the weather. And I'm here to tell you that actually it was a very serious endeavor back in the day. And so this is kind of the one thing that, as a scientist, it kind of rankled me to see this in the movie. And I won't go into other details, but this gives me an excuse on how to talk about this. I'm also going to talk a little bit about aeronautics, and I should mention that Ben Franklin was interested in weather predictions, and he was also interested in aeronautics at that time, and I'll give you some hints to that. Okay, so if you just needed any, I don't know, proof that people for a long time believed that they could predict the weather, all you have to do is go back over time and look at weather aphorisms. And there are tons of weather aphorisms. I was talking with the shuttle bus driver from to Woods Hole for the ferry, and we started geeking out about how to predict the weather without logging on to NOAA or something like that. It's wind directions, that sort of thing. So here are two of many aphorisms that I teach in my course. If dew is on the grass, rain will never come to pass, or also the frost in the pumpkin. And that's because at nighttime, if you have a clear blue sky, all the infrared heat goes out into outer space. So that means it's clear, and so dew on the grass is a result of that. And so that's the kind of physics that's going behind that aphorism. Red sky at night, sailors delight. Red sky at morning, sailors take warning. Surely you've heard that. The red sky at night in particular is interesting because what happens is if you've had a storm that passes by and then all of a sudden the western horizon, there's a gap in the clouds, the sun will peek through there and shine on the bottom of the clouds, giving the reddish color to the sky. So you have to kind of know what you're looking for to apply this one. And I should note that red sky at night, sailors delight has been around for at least 2,000 years, and it appears in Matthew 16:1-4. So Pharisees and Sadducees came to Jesus and tested him by asking him to show them a sign from heaven. He replied, "When evening comes, you say it will be fair weather, for the sky is red. And in the morning, today it will be stormy, for the sky is red and overcast." You know how to interpret the appearances of the sky, but you cannot interpret the signs of the times. So there you have, 2,000 years ago, people were predicting the weather as evidenced by this. So there have been various false starts in predicting the weather. One that I found fascinating is the science of, the practice of astrometeorology. So this was using astrology to predict the weather. And in fact, I've gone through many treatises. I have an almanac of planetary and positions of the sun and the moon that Columbus carried with him on the first few voyages. And if you look at the preface to that, they're basically describing that, if Mars and Venus are in conjunction, it's going to rain a lot, or something like that. And this has persisted for a long time. If you go back in time to the time of Ptolemy, a few hundred years AD, in his treatise on astrology, he also talks about interpreting astrological signs for predicting the weather. Now, as things got more sophisticated, roughly in the 19th century, this started to fall out of favor because actually people could predict the weather without doing astrological charts. So I found that rather interesting. So on to more serious items. Ben Franklin, obviously a fascinating polymath, but He was one of the first people to realize that, at least in our latitudes, storm systems roughly move from the west to the east. And in 1743, there was a predicted lunar eclipse in Philadelphia. And he wanted to see that, but unfortunately there was a storm that came through and obscured the sky. And then when he wrote to friends in Boston telling them about this, friends in Boston said, oh, it's clear for us, we could see that. But then after that, the eclipse happened, a storm moved through. So Franklin deduced that it was probably the same storm, and storm systems moved from west to east. He also had the first description of a nor'easter, basically a low pressure system that's moving up the coast from the south and has the rotation you associate with it while you get northeast winds. He charted the Gulf Stream, and he basically predicted or came up with a hypothesis that as you get up higher in the atmosphere, it gets colder and colder, at least in our part of the atmosphere, known as the troposphere. He was a great fan of aeronautics, basically balloonists at the time, and he had numerous letters, and his son had contact with this gentleman, Jean-Pierre Blanchard, and you can see etching of his balloon there. Those things that look like giant feathers were Blanchard's attempt to try to figure out how to move this thing around at will. Because if you go up in a balloon, you're kind of at the mercy of the winds, and Blanchard wanted to figure out a way how to go in some direction, more or less deliberately. And in this 1984 ascent, he carried along with him a proto-scientist from Boston named John Jeffries. And John Jeffries basically did also what the protagonist of this movie does, take up weather instruments like a thermometer, barometer, hygrometer, and measure profiles of pressure and temperature at different altitudes. And this one took off in London, and I chart here the pathway, roughly speaking, over a modern map of London. And what they did was when they rose to 4,000 feet, they were moving in one direction, and then they rose to 8,000 feet, and the wind direction changed, and they actually were able to kind of move along with that. And Jeffries came up with the idea that if wind is moving in different directions at different altitudes, then you could basically figure out a way to move where you wanted to. All you have to do is go up to a certain altitude where the wind blows where you want, go in that direction, and then drop down. So this is what Jeffries did. And in 1785, Blanchard and Jeffries completed the first crossing of the English Channel in a balloon, which is really quite an interesting feat. So this idea of Franklin's that weather systems in our latitudes move from west to east became more and more developed into the 19th century. And because of that, an amazing prediction tool came into use, which is the telegraph. And here you see a map of the network of telegraph lines and stations throughout Great Britain, and Scotland, and Wales. And in 1854, there was a creation of, in the UK, of a meteorological office. And the idea is that you would have weather observations that would be done at each one of these telegraph stations, and then they would broadcast all of this information into a central office in London. Then this gentleman, Robert Fitzroy, who also was the captain on the Beagle, the famous voyage of the Beagle with Darwin, he became in charge of that meteorological office. And here you can see a report of some of the information that was coming in over the telegraph lines. This one happens to be Aberdeen, and I think it's like 29.39 inches of water, winds out of the southwest, force 5, I think, and other bits of information that go in there. Southwest winds, that's very strong, and when it was received, and I guess this was in 1862, which was the year that this movie was based on, I might point out. So much for ridicule of people doing weather predictions. And they would have these interesting weather maps that I'm not going to go into the details, but they sort of have information about wind and rain and so on throughout the British Isles and predictions for the next day. So already at this point, people were using information to make weather predictions. Now, the one place where it gets a little bit challenging, particularly in the summer months, are localized weather systems. And people here like go out on the water and sail in the summertime, a couple of people. So you have to keep a so-called weather eye out for thunderstorms. And Also, this will figure into a scene or a couple scenes in the movie, so I'll talk a little bit about that. The first thing is that air, warm, moist air, rises, and when warm, moist air rises, as it gets cooler, as you go up in the atmosphere, they condense into droplets, and that formation of a droplet releases a little bit of heat called latent heat, which causes it to rise a little faster, like a hot air balloon, and then that sucks in more warm, moist air from the ground, and sort of turns into kind of a runaway freight train effect, a feedback effect, where it's just kind of pulling in more and more moisture, and it causes the clouds to build up to, I don't know, 30,000 feet or more, with this classic anvil head shape associated with it. And one of the things that gets people into trouble with these is that the surface winds are typically blowing from the east or the southeast, but the whole storm system is actually moving from the west. So I've had people who are kayak guides who will take their clients out, they'll see these storms in the distance, but the surface winds are blowing toward the storms, and they say, oh, that's fine, the storms aren't going to hit us. But the storms are really coming from the west, and so you typically get the surface winds that are blowing towards the storm. When you get like right underneath critical part of the storm, it's still calm, and you get a calm before the storm, and that's where all the air is going vertically. And it can be quite violent at times, and you'll see a scene where this is sort of played out. And then as the droplets grow in size, as they get up into the thunderhead, the droplets become heavy and they start to fall. And as they start to fall, what they're going to do is suck air along with them and create huge downdrafts. And so as a storm hits, you may feel this kind of the smell of grass or something like that, all of a sudden followed by rain. So that's kind of what you expect. So surface winds, calm before the storm, entrainment and downdrafts, and then finally rain. And so this is what you might see in the summertime here. Okay, so that brings us to James Glacier, who is the person that the movie is modeled after. He was a serious member of the Royal Society, also an aeronaut, a meteorologist, and an astronomer. And he was already fairly revered for his thoughtfulness about how to make meteorological predictions and what it takes to put it together. And as I mentioned, he wanted to do two things. He wanted to get a temperature or barometric pressure profile as you go up higher and higher in the atmosphere, and also set a record, because you want to go up as high as you possibly can. And there's this boundary between what we call the troposphere, where all of our weather action happens, and the stratosphere, where the temperature profile all of a sudden changes a little bit. So he wanted to get up to that height and set a record at the same time. So he went up with this gentleman over here on the right. This is obviously a posed photograph. They didn't have helicopters back in the day, so. On the left is James, and on the right is Henry. And Henry was an experienced aeronaut at the time. And here's another place where the movie takes some liberties. There's kind of a vivacious woman who is actually the partner in this. One thing that was true is they got up to what is reckoned to be about 31,000 feet or thereabouts. And there was a valve that you vent to allow yourself to drop down, and that vent got frozen up. And Coxwell had to climb up on top of the balloon in the rigging and actually try to pry that loose and get it down. So there's actually a fairly dramatic scene in the movie where they repeat that. So some truth to it, but a little bit of dramatic liberty, and I don't mind, frankly. But, I'm just giving you my opinion. Okay. So modern predictions. So the modern observation tools, you probably don't see them, but scattered across all the continents are these automated surface observation systems that then broadcast information to a central place, and so you get barometric pressure, humidity, temperature, wind direction, wind speed, and all that. And it goes into fairly sophisticated computer models, which are actually getting quite good. Although at this point, predicting the weather more than 5 days in advance still remains a challenge after all the sophistication. You have radar, so you can track, for example, tornadoes with rotating wind patterns. This slide got a little cut off, I don't know why, but there are places where balloons are launched. I guess you can kind of see the balloon just off in the left-hand corner there. And then they do so-called soundings, which is to get, again, a temperature humidity profile as you go up into the atmosphere, much like what these gentlemen were doing in the balloons. And then you get satellites as well that get large data, and all this gets kind of piled into a computer model, and out comes your predictions for the day. But I should just mention that sometimes you can now do these computer models if you're close in when you have these local thunderstorms, because your eyes kind of are better than the grid spacing of the computer models. Okay, so going back to balloon flights, this one I was interested in for the topic of my book, which is has a chapter in the psychology of spaceflight. And so here you see this gentleman in the lower right-hand corner is Major David Simons from the Air Force, and he worked with who was a Curtis Stapp, who was also in the Air Force, on the effects of what was likely to be manned spaceflight. And so they're worried about G-forces, and they're worried about the effects of isolation, for example. So this kind of shiny device, which is about the size, it's actually smaller than a phone booth, was what Simons got strapped into for a 24-hour flight underneath this balloon that ascended to 100,000 feet. And there was a well-known psychological problem that high-altitude pilots experienced called the break-off phenomenon, where they sometimes felt like they were losing contact with the Earth in some ways, or also possibly losing contact with their own bodies and kind of floating above their bodies. And so, in part, not only was this to try to test out the psychology effects of that, but sort of see how somebody could function. And he reported having break-off phenomenon happen, and also started hallucinating, imagining that there was another person in the capsule with him, and some of his dials started to have faces appear to him, which was rather fascinating. The Mercury program, which was the first single-person flights, were taken in the mostly the early 60s. There was kind of intense attention paid to psychological characteristics for astronauts, but then the results of those were mysteriously shelved, and psychologists could not get access to the data. There's been speculation that these astronauts suffered the same sorts of things that Simons did, and the data were suppressed in some way. So that's also kind of an interesting thing I found in researching my book. Okay, so shameless self-promotion. He said I could do it, so why not? Okay, so I have a book out called The Lost Art of Finding Our Way. It's been out for a while. It serves as the basis for my text for my class that I teach. The students have to learn how to memorize or point out at night various bright stars in the sky, which is actually a nice skill, and they really look forward to doing this. There is an online course, which I think attracted your attention. I'm not sure whose attention it got to, but
Michael.
Michael, yeah. So Backyard Meteorology, the Science of Weather. This is a spin-off from this book, and you can actually take it for credit and get a little certificate if you feel like it. So I go into more detail about how to look at weather signs and the science behind the weather signs and that kind of stuff. So these are all available now. And as a kind of a tag on to that, I started working on a book project, was just about done, and coming out in the fall is a book called A Sense of Space, A Local's Guide to a Flat Earth, the Edge of Cosmos, and Other Curious Places. I'm not a flat Earth conspiracy theorist, but I do make a little light of them. But I also point out in the book that the earliest Greek pre-Socratic philosophers, some of them did believe in a flat Earth, and it was only after a certain period of time that the spherical Earth became part and parcel of the ancient Greeks' model of space. There's a lot of stuff in there about kind of the social spin-offs of different visions of space over the years, and it's kind of remarkable the spin-offs that there are. So I'll leave it at that. And, if you're curious, you can look up this book. Okay, so that's my spiel, and I'll take questions.
Question.
Here, I think they want to.
30,000 feet, the balloon,
Yeah.
the ascent that you were talking about
Yes.
from 1862, I think it was.
Yes. Mhm.
What is the survival situation at 30,000 feet without oxygen? Do they have oxygen? Is that possible?
No, they did not have oxygen, and James passed out. Henry tried to revive him and couldn't revive him. I think Henry, when he was trying to dislodge the valve, almost passed out himself because of lack of oxygen, because they're going up real fast. There's no time to acclimatize. And so, what happens when you pass out? So it's rather remarkable that they were, able to function and bring themselves down safely in that. So, yeah.
Do you want to say something about all the horrendous weather stuff that's going on now and its relationship to climate change?
I can speak to some of that. There's actually a rather remarkable piece of data, which is that you would think with the coverage of the hurricanes that we had, those two landfalling hurricanes, that those would be the effect of climate change. And yet, if you look at the data from the National Oceanic and Atmospheric Administration from 1900 to the present, in sort of decade swaths, there doesn't seem to be a clear uptick in hurricane activity, which is surprising because we're told this on the news all the time. The World Meteorological Organization also just basically repeated this. I mean, I went on the website and did the data and the graphs myself. It's like, why is this going up? We're being told it goes up and it's not. So there are two conditions for hurricane formation, at least in the Atlantic. One is that as these low pressure systems come off the coast of Africa, you have to have warm water temperatures. Check. We do have warmer water temperatures than normal, and that you would think would feed more hurricanes. But then the other effect is a lack of wind shear, and wind shear is kind of what Blanchard and company found when they were ascending their balloon over London, which is that there are different wind velocities as a function of altitude. And to have a hurricane spin up, you have to have less wind shear. So it's conceivable that what's happening is you're seeing the increase in sea surface temperatures on one hand, but you're having increased wind shear on the other hand, and the two things kind of offset each other. And I do know that the one Cat 5 hurricane off Yucatan that then went to Florida, it weakened from a Cat 5 to a Cat 3 because there was significant wind shear off the coast of Florida. So that's one kind of counter data point to the hurricane, at least what you hear about hurricanes. On the other hand, the Arctic is just a horrendous situation because what happens is the sea ice reflects sunlight back into space, and that means it's not getting absorbed in the Arctic. And so as you start to lose sea ice, you get more heat absorbed from the sun, and everybody is saying that we're losing huge amounts of sea ice in the Arctic. So you have to kind of zero in on the effect that you're interested in, isolate and start to ask the question, what climate change signatures are you seeing in that particular effect? That's kind of what I'm doing. Yeah.
Maybe last question.
This is a selfish question. Is there any way to take your navigation course if you're not a Harvard student?
I've had people audit it, and I've been thinking about trying to extend it to an edX program. The only problem is edX went bankrupt. And the other thing is they wanted to become more mercenary. They wanted, to be like, okay, no, we want people who want to learn accounting, and we want to have people who want to, pay to, I don't know, learn a computer language or something like that. This navigation stuff is, it was kind of funny. But you can check out the backyard meteorology course. And I am, in the end, thinking about hanging out a shingle for navigation courses, because I can also teach celestial navigation with sextants and that sort of thing. And so my wife retired, and I live in Harwichport, and I'm thinking, why don't I hang out a shingle and I live right on Nantucket Sound, so, you can use that as a horizon to do your sightings and all that good stuff.